Please help me welcome Navroop and Alex.
Good afternoon, everyone. You've made it to the last lightning talk of the day. We're very excited to share this next presentation with you. My name is Navroop. I'm a TPM here on the cloud team at Modular. I'm joined by my colleague Alex, who's an engineer also on the cloud team. We're here to present to you what a typical developer journey of using the Max platform, which was presented at the keynote earlier today, might look like from local development all the way to deploying your optimized AI models to the cloud. We'll start by talking about what's included in the developer edition and the benefits of inferencing with Max. Next, we'll develop a model application and leverage Max to create an inference pipeline. We'll share details on the enterprise edition of Max. And finally, we'll talk about how to containerize and deploy your models to the cloud via Max. And we'll also leave some time at the end for Q&A. So let's dive in. Let's start by recapping the announcement from this morning. The Max Developer Edition includes the Max Engine, which is the world's fastest unified AI inference engine, and has access to Graph APIs, a state-of-the-art compiler, and runtime. It also includes Max Serving, which allows you to take the engine and easily deploy it to the cloud using existing industry-standard serving systems, such as NVIDIA's Triton, TensorFlow Serving, and TorchServe. It comes with C, C++, Python, and Mojo APIs, and enables you to use container infrastructures such as Kubernetes. It also includes the Mojo programming language, which ties all of this together to give you a unified AI infrastructure with full pipeline extensibility from pre- and post-processing to implementing custom ops for the engine itself. But before we go further, let's talk about why this matters for folks in the audience. Well, with Max Serving and Max Engine combined, you get an end-to-end inference solution that reduces your team's complexity of deployment and allows your team to meet their latency and cost budgets, giving your AI development team profound new abilities. This is going to rock their world. The Max Engine enables a single tool chain that's framework agnostic and portable across different compute platforms, including both CPU and GPU. It serves as a drop-in replacement, allowing you to realize the benefits of inferencing with Max immediately without any rewrites. It also supports a variety of your use cases, from text generation and image generation using large language models and stable diffusion, to code completion with StarCoder, and also has support for your traditional AI models, such as ResNet for image classification and recommenders like DLRM. It also comes with an instant boost in performance, adding compute multipliers to your AI workloads across different frameworks and hardware types. Again, all with zero migration cost. You can get more details on the engine's performance at performance.modular.com. Additional benchmarks for GPUs and Gen AI models are coming soon. So this all sounds great. In the next portion of the talk, we'll show you this in practice. We'll develop a model application, then we'll integrate the engine into our model app via the Max Serving platform. And finally, we'll containerize and deploy it into production on the cloud via Max Serving. In order to demonstrate all this, I'd like to kick it off to Alex.
Thank you, Navroop. Hi, I'm Alex, an engineer at Modular. This is my dog. Her name is Yolana. What makes her happy is when I call her good dog. So I decided to build an application that takes a camera feed or an image and says good dog every time she walks by so that she doesn't feel lonely when I'm not at home, like today, for example, this conference. So let's build a simple version of it and see how Modular can help. To get started, you need to go to modular.com website, install the Modular CLI tool, and then install the Max platform. Max platform includes everything: Mojo programming language, the inference engine, and the inference service. It will be available soon for everyone. Meanwhile, you can sign up for early access at the link below. I'll be developing in a Jupyter notebook. I already prepared my environment and installed the Max platform. Now I can import the engine into my notebook and use it. I can create a session and load a model. I decided to go with DenseNet image classification model. I know it's 2023 and it's not fancy anymore, but it makes the work done. I personally really like that Modular supports all major frameworks, and I can load models in their native formats. I can use the same code and API with any framework. Here we load Onyx and PyTorch variants of the model. Now I can explore the model, its input and output parameters, shapes and types. I can execute it and get predictions back. Now let's take a sample image. The best dog ever. Isn't she cute? So we need to prepare the image for the model. It's a simple pre-processing. We resize the image to the expected shape. We convert it to the expected type, scale it. That's it. Let's execute it. And get predictions back for our image. Now we want to map it to the human readable labels. DenseNet was trained on ImageNet dataset. So if it's a dog or dog breed, I'll output good dog. If not, I'll output the predicted label. We got good dog and made Yolana happy. So what I actually coded above is a simple inference pipeline that consists of 3 steps. Pre-processing that takes the domain data and prepares it for the model. Inference that executes the model and gets predictions back. And post-processing that maps predictions back to domain data. Let's connect all steps together. And create a simple UI for it. I really like Gradio library, which is probably the easiest way to create simple UIs. It's just one call, and I use our prediction pipeline, image as an input, prediction as an output. Here how it looks like. Let's try another image. It's Yolana with her favorite new toy.
Is that a llama?
Yeah, she likes it. Now let's talk about the ways we can use the inference engine in our applications. We are releasing a low-level C library. It's a backwards compatible API and binary interface that you can link into your C and C++ applications, or you can use it in a programming language of your choice. Another option is Python and Mojo packages. It's a high-level API and essentially bindings for the C library. It's easy to use from Python and Mojo code and in Jupyter notebooks. That's what we saw in our previous demo. We are also releasing the modular backend for Triton Inference Server. Triton is probably the most popular inference server for deep learning models. It is open source, created by NVIDIA. It implements the standard KeyServe API that supports both HTTP and gRPC protocols. It is extensible and supports both multiple machine learning and deep learning frameworks, such as TensorFlow, PyTorch, Onyx, and now Modular. It has some advanced features like model ensembles, business logic scripting, dynamic batching, etc. It looks like Modular on Triton provide a lot out of the box. Let's try it out. We ship a reference Docker file with the Max platform that you can use to start locally. It uses NVIDIA Triton as the base image. It copies the modular backend and all necessary libraries into the image. You just need to point it to the local modular installation directory. Triton expects models to reside in the specific layout. We need to prepare it. We also need to create a model configuration file. All we need to set there is to tell it to use modular, and that's it. The rest will be derived automatically. Magic. Then we build it and run it. Now we can use it in our Jupyter notebook. I can import the Triton client. I can create an instance of it, prepare the data, call the inference endpoint, get predictions back, well, and use it. Now that I tested it locally, I want to show it to my dog, Navroop. How do I deploy it to production?
Great question, Alex. A lot of our early access program partners have been asking us the same exact question. They're eager to take Max and deploy it onto their production workloads. So today, we're excited to announce that we will be launching the Enterprise Edition of Max on AWS Marketplace. We're thrilled to be partnering with AWS on launching our Enterprise Edition. AWS Marketplace is the go-to solution for enterprises seeking to deploy Max into their existing services running on AWS, including on EC2, EKS, and SageMaker. With our marketplace offering, you will get access to unparalleled, low latency, and high throughput inference that just works. You'll be able to go to the Max listing on the marketplace and subscribe directly from there. And by doing so, you can deploy the container directly from Marketplace. It works out of the box as a drop-in replacement, and you can use your existing AWS account for billing and procurement. There's no need for additional sign-up. Our Marketplace edition comes packaged with a Helm chart that allows you to build a production-ready inference service that scales up and down natively with demand. And on AWS, take advantage of additional performance gains seen on Graviton instances. With Max, we see up to 5 times higher performance and 80% cost reduction out of the box. This sounds awesome. Alex, why don't we take your demo and run it in production?
Yeah, that sounds great. Let's do it. Before we start, I wanted to mention that there are many ways to deploy your software on the cloud. It can be virtual machines that you manage by yourself. There is ubiquitous Kubernetes that manages containers for you. It can be fully managed services and machine learning platforms. I decided to go with Kubernetes for my application and already provisioned the cluster, so let's go to AWS Marketplace. I opened the modular product page on AWS Marketplace. Here's how it looks like. Now we can subscribe to the product, accept the terms, and go to configuration. Here we see 2 options, container and Helm chart. Container option is great when you want to integrate modular into your existing infrastructure. We also provide a Helm chart. It helps to manage Kubernetes applications and simplifies deployment a lot. Helm chart option also includes the container, so let's go with that. We picked the latest version, and now we are ready to launch. The deployment consists of 2 steps. We create AWS IAM roles and Kubernetes service account. Then we deploy our software using the provided Helm chart. Let's execute those commands. Here I create a Kubernetes service account and grant access to AWS marketplace services and S3 to fetch our models. And it's created. Then let's log in into Helm registry. Now we're able to deploy it. Let's do it. Yeah, just Helm install. We need to set the service account that we just created and point it to the model location on S3. Let's deploy it. And it's deployed. Now let's deploy our awesome good dog application. And deployed. That was quick, wasn't it? What we actually deployed is the whole serving pipeline from our small demo machine learning application to optional load balancers to one or more inference servers powered by the Max engine, and all that by just a couple of commands. Let's see how the application works. Let's try another image. It's our awesome dancer. Wait, is it Mojo predicting Mojo? I'm wondering, does it make Mojo self-aware?
I think we're getting pretty close.
I hope. One more topic I wanted to talk about is fully managed services. I personally love them. They make it easy to build and deploy applications. You use UI, API, code interface, click, click, and it's running in production. Good news. Modular supports integration with AWS SageMaker. For those who don't know, SageMaker is the fully managed machine learning platform by AWS. It helps you to build, train, and deploy machine learning models. That means that you can leverage the Modular Max platform and all its benefits and whole AWS SageMaker ecosystem. You can use SageMaker client to deploy modular in the fully managed way. Let's take a look at it in action. I opened a Jupyter notebook, installed all necessary dependencies. I create a SageMaker client. Then I specify the modular container image, model location, and model name I want to load. Then I create a SageMaker model with those parameters. Then I create a SageMaker endpoint configuration where we can set instance type and number of instances we want to run. By creating SageMaker endpoint, we actually provision the instances and deploy our containers. Once it's started, we can use it. We can prepare the data. We can use the SageMaker client to call the inference endpoint and get predictions back. And all that powered by the awesome Max platform. One more point I wanted to emphasize one more time is that modular works as a drop-in replacement for existing frameworks. If you already have services running in production, then switching to modular is as easy as changing the container image and model configuration to modular. That's it. So this is the last demo I wanted to show. Navroop, what did we learn today?
Great demo, Alex. By the way, Yolana's a beautiful dog.
Thank you.
And by the way, if you didn't already realize, Alex is deeply passionate about shipping models to production. So as we saw Alex do here, we configured the Max engine to be used as a drop-in replacement for the model serving application with only a few lines of configuration. We then deployed this model serving pipeline to AWS via Max Serving and scaled it up on Kubernetes using EKS. We even saw Alex integrate this into a SageMaker workflow. Although this demo app focused on a simple image classification model, Max supports all your Gen AI and traditional AI models. And it comes packaged with several APIs to enable your application development. In addition, both the Max Engine and Max Serving are fully extensible, allowing you to write your pre- and post-processing steps in Mojo. This means that you get all the extensibility and programmability of the Max Engine, including the ability to write custom ops, which was shown in an earlier Lightning talk, with the Max Serving platform as well. Together with both of these, you get an improvement in performance in your holistic end-to-end inference pipelines. In fact, we observed many multiples of improvement in throughput using Max over the stock TensorFlow and PyTorch backends. And the results are especially pronounced on Graviton 3 instances, with over a 5x improvement in throughput with certain models. The same is also true for reducing the cost of inference. With Max, we observe significant cost reductions across the board on various model types and hardware SKUs, with over 3 times cost savings enabled on Graviton. And we're excited to bring all of this to you very soon. The developer edition will ship with the non-commercial license and will allow you to deploy on up to 16 vCPU cores for single node inference. It will be available for free starting in Q1 2024. The Enterprise Edition will be coming first exclusively to the AWS Marketplace and will ship with a commercial license that enables unlimited distribution. You'll be able to scale up horizontally to as many nodes as you would like. Pricing will be pay-as-you-go and consumption-based, and this will be available also in Q1 2024. We're beyond excited to bring both of these offerings to you very soon and can't wait to hear the feedback from the community. Thank you very much for listening to our presentation, and we'll open it up for questions now.